Once we have the entire class implemented, so once we've written out myArrayList in the code, we can create a client program that would actually implement these main features of the list. So we can create an object of the class, and then we can add items to the list, we can print everything in the list, we can remove items, we can set items, and so forth. And the big thing I want you to take a look at when we see this code is, aside from the fact that this class is called myArrayList, there's nothing in the client that tells us that we're using an array as our underlying data structure. In fact, if I were to rename the class to something else and you take a look at it, you wouldn't be able to tell that we're dealing with arrays. You wouldn't be able to tell what the underlying data structure is. That's our goal when implementing these abstract data types. Now, we can see in the client the methods that we're calling, so we know what's going on, but we don't know what is actually happening or how it's going about it unless we were to look at the class that implements all of these operations. Let's actually go back to our myArrayList class and create a client for it, just so you can see that we can create objects of this class. And what we'll find is, aside from the fact that we have the word array, we're not going to really see that we're using an array for this class. So we need to create a new file. And let's see here. We'll go ahead and import the java.util package just to be safe. Java.util.star. We'll create our class. I'm going to call it myArrayClient. And then we'll create our main. So the first thing we'll do is create an object of this list. So we can do myArrayList. We do need to specify the actual data type here, because remember, we had this any type, and that means that we can put in whatever data type we want. So let's just do integers. So we'll put integer in the angle brackets, and then we'll call this myList. So set it equal to new myArrayList with integer. All right, so let's just do a couple things here. We need to add some elements, so let's go and do some adding. So we'll do myList.add. So let's do 5. Let's do a couple. 10, 15, 20. All right, so we've added a couple things to the list. Let's go ahead and print the contents of the list to make sure that this worked properly. So let's do a for loop. Let's do I equals 0, myList, and we can take advantage of the size method. I++. We'll do system.out.println. We need to get the value at a particular element, so we'll do myList.get I plus and then a space. That way we would print, actually not print line, we'll do print. There we go. That way we print everything on one line. So what this does is we're going to print the first iteration, we're going to print the element at index 0, then index 1. And you might be thinking, well, couldn't we just do like myList with square braces 0? Well, we can't, because if we look through here, first of all, the underlying array is private, so I can't directly use the array, but I can use the corresponding method. Let's go ahead and save this for now. And let's just try this real quick. So let's compile to make sure it works. There is a warning. Uncheck cast. This warning should be fine. We're not going to worry about this one. So we'll run it. And sure enough, we see it does print 5, 10, 15, and 20. But there are other things we can do with this. Let's try printing the contents again. Except now we're going to use that iterator that we have. We can create an iterator, and we can print stuff with it. So let's try out some of the stuff from the iterator. So we can do iterator, and we have to specify the type, so it'll be an integer. So we'll call it iter1. I may create a couple of iterators. So we'll do equals myList.iterator. And so we can do a while loop and say, well, iter1 dot has next. So this is saying as long as there is still an element in the array and the iterator is not at the end, we can print the contents of the iterator. So we can do system.out.print and then iter1.next plus, and then some quotes, So this iter1.next is going to print the contents of the current iterator, then it moves on to the next. So let's see what that does, just to make sure that worked properly. So let's compile. We still got that warning, that's fine. Let's go ahead and run it. And we see that it does print the contents of the array again. So this iterator does work. Okay, so we can print the contents, we can use iterators. What else can we do? Let's say we remove an item. So let's say I'll create a variable called x, and we'll say mylist.remove. And let's say we want to do index 2. So we're going to remove the value or the element that's at index 2. And then we'll use an iterator again. And let's just print the contents of the array. So I'm going to create another iterator. Because remember, I can't use this iterator 1 anymore. It's no longer valid because we changed the array. So integer, I'll call it iter2. Mylist.iterator. And actually, I'm just going to copy this here just to save myself some typing. We just need to change it to iter2 instead of iter1. Okay, so let's just test that real quick to make sure it worked. So if we run it, we see that it did remove the 15. So 15 was at index 2. So when we printed this stuff with the second iterator, it printed 5, 10, and 20. So it looks like that worked. Let's do one more thing. Let's say we want to change one of the elements. So let's just do mylist. We can use the set method, and we're going to change the value at index 1, and let's change it to something like 12. Okay, so now we need to use the iterator to print again. I'm just going to copy everything here. We'll paste. Instead of using iter2, we'll create a new iterator, because once again we changed the list. So just to be safe, we'll create a new iterator, which we'll call iterator3. So let's save that, compile. We still have that warning, that's fine. Let's go ahead and run it and see what we get. So sure enough, we have our first print from before. We have the print with the first iterator, the print with the second iterator, and we see at index 1, we change it from a 10 to a 12, and we printed all 3 elements of the array. So we can do all sorts of stuff here with the client, but once again, I really want to iterate here. No pun intended with the iterator, by the way, but I really want to emphasize that aside from the word array here and here, there is nothing in here that clearly tells us that we are using an array as the underlying data structure. Sure, we have the get method and we're specifying a spot, but who's to say that's not using the linked list approach and we just use some other way to actually get the element or the item at that particular spot. And that's really what I want to get at here, is that we can set up our methods in our class such that we can't tell what is the underlying data structure unless we look at the details of the class. We're now going to take a look at a Java concept that's used with our iterators, which we call nested classes and inner classes. Now, the ArrayList iterator class actually uses a new Java construct we haven't talked about before, which is called the inner class. Now, this is a little bit tricky to comprehend at first. So, obviously, this is a class that's declared inside of another class. However, an inner class in Java does have a more subtle property. To see how an inner class works, we're going to take a look at a portion of myArrayList. So here is our code. So we're importing the java.util package. We have public class myArrayList, any type implements iterable, any type. We have the size and the array of items, and we'll have a whole bunch of stuff in there. And then we have our iterator method where we are creating a new object of the ArrayList iterator class. So this line right here is going to create a new object of the ArrayList iterator class, and we're going to return the address of that object. And then here is the rest of the code in the same file. So we have our class ArrayList iterator. It implements the iterator interface. We have the current, which represents our current position, is initially 0. We have implementations for our hasNext and next methods, so we can check to make sure that there is still something in our collection or in our list. And then our next method does give us the next item in our list. Now, I do want to mention something about that example, It was kind of hard to tell because we had to split the code within 2 slides, but the idea with that example was both of those classes were in the same file. So we can actually have multiple classes in a single Java file. The way we pull that off is exactly one class must be public, and the name of that Java file must match the class indicated as public. So in our example there, we would have had myArrayList.java because the class that was designated as public was the myArrayList class. And then all of the other classes that are included in the file cannot have any modifiers before it. That's why if you take a look at the previous slide, the ArrayList iterator class did not have public or private in front of it. It was just class ArrayList iterator. Now, I should note that the current code that we gave is not correct. So we'll see why in just a second. So what we're doing here is we're attempting to use the current position in next to index the array and then move on to the next element in the array. So let's note that if ARR is an array, I'm just going to call it R, then our IDX++ uses our index IDX to get the value at our IDX, and then we're going to increment IDX. So note that it's important that the plus plus goes after the IDX and not before IDX. So what we're doing here is we're getting the current value at the current spot, and then we're going to increment IDX, so that way the next time we would call next, we would get the next item in the array. But the big problem with this approach is that the items array, that is legal. This whole line, the items with the square braces current plus plus, that's illegal because the items array is not part of the ArrayList iterator class. It's part of the myArrayList class. So if we try to compile it, it's going to say in this class, which as the way it was implemented, it's a separate class from the myArrayList class. It's going to say, I don't know what the items is. That's not declared in this particular class, so I can't use it because it's not declared. Another issue we have is that the size method is also not defined in ArrayList iterator. It's defined in the myArrayList class. So both the items array and the size method that are currently being used in our ArrayList iterator class do not even exist in that class. We're trying to use something that isn't declared there, so Java's going to come back and say, we can't do this. You're going to get compile errors. So how do we fix that? Well, we'll see how that's done in the next class.